Cosmology is the study of the universe as a whole, and it asks questions about the origins and the eventual fate of our universe. Its most famous contribution has been the Big Bang Theory. The Big Bang Theory claims that in the past, about 14 billion years ago, all the space and matter that makes up our universe as we know it was compressed into an extremely hot, extremely dense, tiny volume, minuscule in size. And that an extraordinary explosion caused this space to expand. As the space itself expanded and all the stuff packed into it therefore became more spread out, it cooled down, and eventually atoms could form, and then stars and galaxies, alongside planets and life. This theory is extremely precise, detailed, and in good agreement with experiment, and the GCSE course only intends to introduce it in its simplest form, and include some of the evidence that supports it. The two bits of evidence we will look at are the cosmic microwave background radiation, or CMB radiation, and galactic redshift. The CMB radiation can be summarized as follows. After an explosion of the magnitude of the Big Bang, we would expect there to be a lot of energy in the surrounding space, a sort of afterglow of the explosion. We can calculate how much energy we would expect there to be at a given time right after the explosion, and we can calculate from that what we would expect this afterglow to look like to us now, 14 billion years on. This afterglow is what we call the cosmic microwave background radiation, and we have managed to detect it all over deep space, and it's in perfect agreement with the theory of the Big Bang. This CMB map here is the biggest map we have of our universe, and shows us the boundary of what we call our observable universe. The second bit of evidence for the Big Bang theory is called galactic redshift. Redshift is a phenomenon of waves. Consider a person who is inside an object that's giving off waves. They can be light waves or sound waves, it doesn't matter. If you are standing still next to the object, you can measure the wavelengths of the incoming waves, and the person inside the object would agree with you on this wavelength. If, however, this object started moving away from you, you would actually measure a new wavelength coming off the object, one that is longer than before, whilst the person who's moving with the object would still measure the same wavelength as before. The opposite is also true. If that object were moving towards you, and you measured the wavelength of the light it was giving off, you would measure its wavelength to be shorter than the person in the object would measure it to be. It is as if the object moving towards you compresses the waves, and moving away from you stretches them out from your point of view. If these were in fact sound waves being given off, the effect you would notice would be a higher pitch noise when it comes towards you, and a lower pitch one when it goes away. If the waves were instead light waves, the effect for you would be the light looking bluer as it moves towards you, and the light looking redder as it moves away from you. And with light we can easily quantify this effect. Let's say the object is moving at a speed v, and the person in the object measures the wavelength of the light being given off to be lambda. We measure a shorter wavelength, and the difference between what we and the other person measures we call delta lambda. The equation states that the speed of the object divided by the speed of light c is equal to the change in wavelength, delta lambda, divided by the original wavelength, lambda. When looking out to space, we have observed that galaxies far away from us appear redder than we would expect, and so we conclude that these objects must be moving away from us, and the light that they are giving off being redshifted. We also see that the further away a galaxy is, the more redshifted its light is, and so the faster it must be moving away from us. This supports the Big Bang theory, which says that space is expanding, and so things will look like they are moving away from each other.